All right, guys, so what we're starting today is Chapter 7. Chapter 7 are rational expressions, rational equations is what this chapter is going to be over. So part of the reason we went over factoring and doing factoring again is factoring is going to be an essential part of rational expressions, rational equations. Because if there's something in common on top and bottom, we're going to have to simplify it out. And now since we're talking about equations, we're actually having expressions. We need to be able to factor quadratics or higher degrees, polynomial expressions, to make sure if there is something in common with both, we can factor it out. I need to go back and adjust these so they're not as grainy. But the first thing we're looking at is inverse variation, direct variation, inverse and direct variation. Now, direct variation is given to us by this equation here. It is in your notes up there at the top. Direct variation, y equals a times x. This is one way the direct variation is written. Y equals a times x. And when we talk about direct variation, we're saying that we're relating two values, and as one increases, the other is going to increase. And as one decreases, the other is going to decrease. They're going in the same direction. They are directly related to each other. And a, that letter a is just a number. It's just a constant term that's going to tell us how much they are increasing from one term to the next by. So we could say direct comes in the form of y equals a times x, or if we actually solve for a, we divide both sides by x. We can say that y over x is equal to a. Or realistically, we can say x over y is also equal to a. We're just dividing it, getting the variables by themselves. Is direct variation. As one increases, the other increases. As one decreases, the other will decrease. And they will increase or decrease proportionally to each other. Now, the other one we have is inverse variation, y equals a over x. And with inverse variation, as one increases, the other is going to decrease. Or as one decreases, the other is going to increase. They're going to be going in opposite directions, or they're inversely proportional to each other. Now, if we solve for a just like we did with direct variation, we can also say that x times y is equal to a. Yes. Questions on inverse variation or direct variation? So what we're going to look at first is see which of these equations, see if these equations are direct, inverse, or neither, because they don't have to follow or be under specifically direct or inverse variation. There are other equations or other relations that can occur. And if we look at letter A, x times y equals 5, and we want to determine if this is direct or inverse variation. One of the ways we can do this is look at the equations and see how they relate to it, if it's in the form of y equals a times x, which is direct, or inverse, y equals a divided by x, or a equals y over x, a equals x over y for direct, or x times y equals a for inverse. So what do we think about a? Direct is inverse. Because one of the ways we can say it or just match it up, x times y equals a. A is just a number. A can be any number that we want it to be. 5, 1/5, 2/7. It's just a value. X times y equals a. Now, the other way we can do this is that we can take the equation and get y by itself. we can solve it for y. And to solve it for y, we would divide both sides by x, telling us y is equal to 5 over x, which is matching up our standard form of inverse variation, y equals a over x. We have this here. Questions on this here? Another way we could check for inverse variation, especially starting with our given form, is I can just pick a value for x. It doesn't really matter what it is. I just pick a value for x. So I'm going to pick 2. And what we'll do with that value is we plug it into this equation. We're saying that 2 times y equals 5. I'll solve it for y to just see what its value is. And it tells me that y is 5/2, and that's fine. Next thing I'm going to do is increase the value of x. I want to see what y does. Because if this is direct, y's value is going to increase proportionally. If it's inverse, it should decrease since x increased. So we have 3 times y equals 5. Divide both sides by 3, and y is equal to 5/3. It got smaller. So it's telling us it's possibly inverse, and we would try other values to make sure. But questions on first one, inverse or direct? Let's look at B. Y equals x minus 4. Does this match up with our direct or inverse? No. What is the one thing it has that neither one of our general forms has? Subtraction. This is neither. This is definitely neither. If we have addition or subtraction, it's not going to be direct or inverse. Direct and inverse variation is going to be dealing with multiplication. Let's look at C. Y over 2 equals x. So this actually is going to be direct or inverse. This will be one of the two. But this one might be a little harder to see because we have y on top over 2. Y over 2 equals x. Now, since we do have division, it is tempting to say that this is inverse, but it's actually going to be direct. Because another way we can look at y over 2 equals x is that this is the same as 1/2 y equals x. Both of the variables are on top of the fraction. They're in the numerator. Because inverse, y equals a over x, one of the variables on top, one of the variables is on bottom when they're on opposite sides of the equation. As for inverse, one's on top, one's on bottom. Direct, y equals a times x. X equals a times y. Both of the variables are on top of the fraction. Here, both of the variables are on top of the fraction, so this is actually going to be direct, because we're looking how do the variables relate to each other? How do they work together? Both of them are on top. Questions on C? Another way we can look at this, or see it, is we get y by itself. And if I wanted to get y by itself with this here, we can multiply both sides by 2. Because 2 times y over 2, well, the 2 and 2 would cancel each other out, telling us that we have y is equal to 2x. Y equals a times x. It is direct variation. Questions on this here? Let's look at 1, 2, and 3. Number 1, 6x equals y would indeed be direct variation. How about number 2, x times y equals negative 0.25? Inverse. Y plus x equals 10. Neither. I think we're getting the hang of this. A, x times y equals 17. Inverse. Y equals x plus 29. Neither. and y over 10 equals x? Correct. So there's, as you see here, especially identifying them, there's many different ways to look at it, many different ways to approach it. Whichever way you see them or can think of them and connect them together, do that. Work with that method. I'd also say, especially as you're taking notes or going through this here, if there are key questions, especially as I'm asking them, that you find helpful for remembering, write those down. That way you can start asking those questions as you work through. Because again, I'm going to try to keep emphasizing this more and more. I would focus more on the process than what the numbers are. If the specific numbers or the specific setup is important, I will put an emphasis on it. All right? Because if we know the process, we can do any of them. Now, here, again, doing the same thing. We want to tell if this is direct, inverse, or neither. But unlike last time, they did not give us an equation. They gave us the numbers. And the nice thing with directed inverse variation is the change, our rate of change from one term to the next. As x increases, y should increase by the same amount from term to term. As x decreases, the amount of change in y should also change proportionally. Because as we said, direct variation is y is equal to a times x. In inverse, y is equal to a divided by x. That amount, that value of a, should be the same no matter which value of x and y we have. Now, as we look at a, we can do direct variation first. And direct variation is y equals a times x, or a is equal to y divided by x. Because we're just getting that value of a, that constant amount by itself. So if I take the y values and divide them by the x, or proportionally x divided by y, and I get the same amount every single time, if we get that same value of a, it's going to be direct variation, because that should be a constant amount. So if we looked at this here, I can start off, take the y value of negative 12 and divide it by 2. I'm taking the y value and dividing it by its corresponding x. And negative 12 divided by 2, negative 6. We can go to the next one. Negative 6 divided by 4 is negative 3/2. They do not divide nicely. Now I could keep going from here, and we can do negative 4 divided by 6, negative 3 divided by 8. But I do not have to. Because for these to be direct variation, that amount of a, that value of a, has to be the same all the way through. So because we got negative 6 for our first term, constant value of a, and then got negative 3/2, those are not the same. It cannot be direct variation. As soon as we get one that's different, it tells us it's not it. So you can write it right below it, because our other option for this is inverse. Y is equal to a divided by x. But again, we're wanting to see if that value of a, if that's a constant amount for all the terms. So we can get a by itself. I just multiply both sides by x, telling me a is equal to x times y, if we multiply the two together. Now the first one we have is 2 times negative 12. And that would be negative 24. We're just multiplying the two together. And that's fine. We can move on to the next one, 4 times negative 6. And 4 times negative 6 is negative 24. Then we can do 6 times negative 4, which is negative 24. And 8 times negative 3 is negative 24. We got the same value for a in all 4 spots. So that tells us what this is. inverse variation. Questions on this here? Now, unfortunately, just because we rule out direct variation doesn't mean inverse is necessarily the correct answer, because we do have the third option of neither. And I would always make sure to check every single one, because there is a time or two that they will make it work. Do we get the correct value of A from the first three, and then the fourth one throws the whole pattern off? Questions on A before we look at B? Does it matter which one we try first for B? No. I would look at the numbers and see, does it look like they're both going in the same direction, or they're going in opposite? Is one going away from 0 and the other going closer to 0? So if we look at B, we got 1, 2, 3, 4 for X, Y is 2, 4, 8, 16. It looks like they're going in the same direction, yes? So let's try direct variation first. Direct is our X over Y, or Y over X equals A is our direct. We good? So we're going to take each Y value and divide it by A, our X value. So 2 divided by 1 is 2. Our next one, 4 divided by 2 is 2. Our next one, 8 divided by 3 is, well, 2.6 repeated. So we got the first two having the same value, but the third one did not work, so this is not direct. Now our X times Y equals A would be our inverse. So the first one we would have is 2 times 1 is equal to 2, yes? Our next one is 2 times 4 is 'Now I did notice, because especially the first one, I actually switched the X and Y, I put Y first, but that doesn't make a difference. As long as you're multiplying the X and Y of the same ordered pair, that's what matters. Questions on this here? Incidentally, this is an exponential. Yeah. Because this is Y equals 2 to the X. Is this equation? Questions on either one of these here? We ready for the next one? Number 4. Our X values are -4, -3, -2, 1. Our Y values are 20, 15, 10, 5. Do we want to try direct or inverse variation first? Direct. So direct is going to be our Y over X equals A is our direct. So we can start off with 20 over -4. And 20 divided by -4 would be -5. Then we can go to 15 divided by -3, which is -5. 10 divided by -2, -5. And lastly, 5 divided by -1, -5. So this would indeed be direct. Now again, Y over X, X over Y does not make a difference in which one we have. They will both work. Because if we did X over Y, we flipped it, we would get the same amount, but we wouldn't get -5. Because we would have -4 over 20, which would be -1/5. -3 over 15 would be -1/5. -2 over 10 would be -1/5. And well, -1 over 5 is indeed -1/5. By flipping the X and Y, all we did was take the proportion and flip it. So it's still direct. So we're looking at inverse. And the inverse would be a place I would start with this set here. Guys, let's focus in. Because as we look at the x values, we're going 1, 2, 3, 4. We're going away from 0. The y values are going 60, 30, 20, 15. We're approaching 0. One's going away, one's approaching. They're going in opposite directions. They are inversely proportional. So we can say 1 times 60, which is, well, 60. 2 times 30 is 60. 30 times 20 is 60, and 4 times 15 is 60. So this is inverse. Questions on this here? Let's look at these next two. 2, 3, 4, 6, negative 4, 6, negative 4, negative 3, negative 2. So as we look at this here, we can try both, direct or inverse. So x's are increasing. They're going away from 0, yes? Y values, are they going towards 0 or away from 0? Towards 0. So there's a good chance, if it's going to be one of them, it's probably going to be inverse. And if we check inverse, that's going to be our x times y equals a, this constant amount. So we can start off with 2 times negative 6. And 2 times negative 6 is negative 12. 3 times negative 4. 3 times 4 is 12. Positive times a negative makes it a negative, so we get negative 12. Then we'd have 4 times negative 3, which is, well, still negative 12. We just flip the signs from the previous two. And lastly, 6 times 2, negative 2 is, well, negative 12. So these are indeed inverses. Questions on these so far? Now, when we look at it, especially increasing, decreasing with x and y, I would think of it less of the sign or value itself as more of where it's going. Because if we think of it as an increasing, decreasing value, negative 6, negative 4, negative 3, negative 2, those values are actually getting bigger. According to the properties of negatives, a smaller negative number is bigger. So negative 2 is bigger than negative 6. So it is increasing. And 2, 3, 4, 6 is increasing if we think of it in terms of the values. It's better to think of it as where it's approaching in reference to 0. Negatives are going towards 0. Y values are going towards 0. X is going away. They are going in opposite directions of each other. If we think of it that way, it's easier to see inverse and direct. Now with B, x values are 2, 4, 6, 8. Those are going up by 2. Y values, 24, 16, 12, 4. That's going towards 0. Going away from 0, going towards 0. So there's a good chance that we have an inverse variation again. So we can multiply these two. 2 times 24 is 48. 4 times 16. We don't have to do these in our head. We can use a calculator, figure that out. 4 times 16 is 64. So it is not inverse variation because those are definitely not increasing or do not have the same proportion. Our other option is direct variation. Y over x equals a. Well, 24 divided by 2 is 12. Our next one would be 16 divided by 4, which is 4. So this has to be either also. Just doesn't work. Questions on this here? We feel pretty comfortable with this so far, identifying direct inverse variation given equations or sets. It's not too bad once we start seeing the relationship, how they work together. The only other thing we have that we're going over is this here. We want to find the equation, the inverse equation from the given information. So we know they have to be related and work together with that constant amount. So they're going to give us two pieces of information. One, y varies inversely. So the variables x and y vary inversely. So we know the equation we're looking at in the general form is y equals a over x. That's the general equation for inverse variation. Now these problems are going to ask for two things. One, it wants to know the equation itself. And two, it wants us to find a y value from a given x. So they tell us x and y vary inversely. And y is equal to 4 when x is equal to 3. Write an equation that relates x and y. Then find y when x is negative 2. So two things we have to find. One, we have to find the equation. And two, we have to find the value of y when x is negative 2. Those are the two things we need to find. But in order to find the y value when x is negative 2, we need to know the value of a. Now there's two main ways to get there. One, and essentially they're both the same, we set this equation up. 4 is equal to a over 3. And all we do is take the equation, y equals a over x, replace y with its value of 4, and x with its value of 3. Solve for a. So the first thing we can do to get a by itself is to multiply both sides by 3. And the reason this works is on the right-hand side, a over 3 times 3. The 3 would multiply with the top, giving us 3a over 3. And well, 3a divided by 3 is just a. They simplify out. Now on the left-hand side, 3 times 4 is 12. So a is 12. Telling us that the general equation for this here is y equals 12 over x. So there will be some like this on the homework. This is half the answer. Y equals 12 over x. We need the equation. Questions on how we found a and got the equation? Now, I did say there was two ways we could get value of a, because this here is one of them, yes? What was the other equation we had for inverse? X times y equals a, yes? Well, x in this case is 3, y is 4, so we could plug the value of x and y in there. And we'll get 3 times 4 equals a. They're telling us that a is 12. Exact same process. Questions on this so far? We need to find y when x is negative 2, yes? So to do that, I'm going to take the equation we got, y equals 12 over x. And we're going to replace the x value with negative 2. So y is negative 6. We replace x with negative 2 because that's the value it asks us to find the y value for. Simplified. If it does not simplify nicely, a non-repeating or a repeated decimal, actually it would mainly be a repeated decimal, we don't have a nice 2.5, a nice integer answer, leave it as a fraction. Fractions work just as well. So the answers for this here is y equals 12 over x. and y equals -6. Questions on this here? So you need both of these, because it does ask us to, one, write an equation, and two, find y. Yep. Now, the centerpiece that we did to find a, you don't need both, because they gave us the same value. We just have to pick one of those two methods to find it. Do we like the x times y equals a version, or y equals a over x? XY is a little bit nicer, yes? Especially for inverse variation, because it says they just multiply the two together, and we get our answer. The variables x and y vary inversely. So our general form is y equals a over x. When y is equal to 8 and x is equal to 4, write an equation that relates x and y, and then find y when x is equal to -16. Now to find a, and I think y'all agreed to find a, this is the nicer of the two equations, x times y equals a. We don't have to solve anything, we just plug x and y in. So x is 4, y is 8. So we're saying 4 times 8 equals this value of a. And 4 times 8 is telling us that the value of a is 32. Which means our general form, the equation itself, y equals 32 over x. Questions on how we found the general form? And we need to find y when x is -16. So we're going to replace the x value with its value, x with its value, -16, telling us y is equal to 32 divided by -16, so y is -2. Questions on this here? I think there's one more of these. Yes? Ready for the last one? I think there's 3 of them. Find when x is 2. So this here will be essentially like the homework. It will tell you the x and y values that vary inversely, but you're going to use the same value of x in all 3. Right. Let's look at number 8. X is 1/2, y is 16. So again, we need to find the equation and to find the value of y when x is 2. So to find the value of a, again, we can use the formula, the equation x times y equals a. This is our equation form for inverse. So it's telling us here x is 1/2 and y is 16. So we're saying 1/2 times 16 equals a, where a is equal to 8. Which means the general form for this here is y is equal to 8 over x. Now, it doesn't say directly there, but up in the directions, it does say then find the value of y when x is equal to 2. So all we have to do at this point is replace x with 2, telling us we have y is equal to 8 divided by 2. So y is 4. Questions on this here? Do we feel comfortable with this here as finding the equation and value of y given a value of x? Right. If we feel comfortable with this, we'll move on. And that is it for 7-1. So 3 through 8, on problems 3 through 8, you're identifying if the equation is direct inverse, or neither. 11 through 14, they give you a set of values, and you need to determine if that set of coordinates or ordered pairs is direct, inverse, or neither. And then 15, 16, and 17, or 15 through 18, given the x and y values, find the equation, and then find the value of y when x, I believe, is 3. It's either 3 or negative 3, one of the two. But it's up there in the instructions.